Today we are learning about complex analysis. It is from MSc 4104 in Barampur University. As you know, iota equal to root over of minus 1, which does not belongs to real number. See, I equal to iota root over of minus 1. Euler introduced iota. Who introduced iota? Euler introduced iota. Z equal to x plus iy. It is also written as xy, which is in argand plane. Here, real part of z equal to x, real part of z and imaginary part of z, which is y. If x equal to 0, then z equal to iy, which is purely imaginary. X equal to 0, so z equal to iy. If y equal to 0, z equal to x, which is called purely real number. The complex conjugate of z, x plus iy, is z bar equal to x minus iy. Z bar is complex conjugate of z. Now these are some example. 3 plus 2y equal to z, then z bar equal to 3 minus 2y. If z equal to minus 3 minus 5 pi, then z bar equal to minus 3 plus 5 pi. These are the conjugate of those numbers. If z equal to x plus iy, then real part of z equal to x equal to 2x by 2. How this is formed? Because the real part of z equal to z plus z bar by 2 and imaginary part of z equal to z minus z bar by 2i. So from that formula we gain real part of z and imaginary part of z. Then we shall learn about geometrical representation of complex number. If z equal to x plus iy equal to xy, then the representation of complex number is called Argand diagram. Then algebra of complex number. Z1 Z1 equal to a plus iy, ib and z2 equal to c plus id. Then the addition of z1 and z2 is equal to real part plus real part and imaginary part plus imaginary part. A plus b, a plus ib plus c plus id equal to a plus c plus I get common and b into b plus d. Similarly, z1 minus z2 and z1 into z2 equal to ac minus bd plus I into ad plus bc. We have learned this before. Similarly, z1 by z2 equal to a plus ib by c plus id. We can convert this into x plus iy form by multiplying c minus id in both numerator and denominator. That is a plus ib into c minus id by c plus id into c minus id. So ac minus bd plus I into polar form of complex number. Z equal to x plus iy, then x equal to r cos theta, y equal to r sin theta, then r equal to root over of x square plus y square. We get this from Pythagoras theorem also. Then tan theta equal to y by x, then theta equal to tan inverse of y by x. Z equal to r e to the power I theta is Eulerian theorem, where e to the power I theta is cos theta plus I sin theta. This is known as the polar form of complex numbers, where r is modulus theta equal to argument of z. It is argument of z is denoted as small argument of z equal to amplitude of z, and principal argument is denoted as capital argument z. See here, this is the principal argument. Argument of z equal to argument z plus 2k pi, which is argument of z equal to principal argument plus 2k pi. This is de Moivre's theorem. which is cos theta plus I sin theta to the power n equal to cos n theta plus I sin n theta. Those are some exercise. 1 plus 2i to the power whole cube. Simple a plus b ro whole cube of a plus b, a cube plus b cube plus 3a square b plus 3ab square. Then you will get this. Similarly, this is multiplied by conjugate of this, that is minus 3 minus 4i in both numerator and denominator. Then you will get this. Similarly, this also, square of this by square of this, that is 3 square plus 2 square, that is 13. A minus bi plus bi equal to a square plus b square. This is an important number, that is 1 plus I to the power n plus 1 minus I to the power n. So from this root 2, that is root 2 cos pi by 4 plus I sin pi by 4 to the power n. Here root 2 is the r, that is root over of 1 square plus 1 square. This is written in the polar form. So root 2 to the power n get common, n cos n pi by 4 plus I sin n pi by 4 plus cos n pi by 4 minus I sin by 4. I sin n pi by 4 got cancelled out. Then root 2 to the power n into 2 cos n pi by 4. This formula is from de Moivre's theorem, that is cos n theta plus I sin n theta equal to cos theta plus I sin theta to the power n. Now if z equal to x plus iy, then z fourth equal to this, that is x plus iy to the power 2 to the power 2. So we can get this. And also 1 by z equal to 1 by x plus iy, then x minus iy by x plus iy into x minus iy. These are very simple questions. Now see what is absolute value of z. So absolute value of z is equal to modulus of z. It means modulus of z. Now find the four values of minus 1 to the power 1 by 4. Here x equal to minus 1 and y equal to 0. If z equal to x plus iy, then x equal to minus 1 and y equal to 0. So r equal to root over of x square plus y square, that is r equal to 1, and we get theta equal to pi by tan inverse y by x, that is tan inverse 0, which equal to pi. And here we have to determine the four values of minus 1 to the power 1 by 4. So here n equal to, clearly n equal to 4. So for k equal to 0, here is the formula, r to the power 1 by 4 and cos theta plus 2k pi plus I sin theta to the power 1 by 4. So by de Moivre's theorem, that is equal to cos theta by 4 plus 2k pi by 4 plus I sin theta by 4. For k equal to 0, see, for k equal to 0, here we have put k equal to 0. So we get 1 into cos pi by 4 plus I sin pi by 4. Here theta equal to pi, so theta equal to pi by 4. So 1 by root 2 plus I by root 2. For k equal to 1, 1 into cos pi by 4 plus 2, 1 into pi. Similarly, you can get this. For k equal to 2 also, just put 2 in the place of k. Then for k equal to 3, now see some question of the exercise. Compute these. See, root over of I equal to x plus iy, then squaring in both side I equal to x plus iy whole square, that is equal to x square minus y square plus I into 2xy. Then comparing the real parts in both side and the imaginary parts of both side, x square minus y square equal to 0. X square minus y square equal to 0, that is 0 plus I. So 2xy equal to I. I 2xy equal to I. So 2xy equal to 1. By solving this, you will get x square plus y square equal to 1 and x square minus y square equal to 0 from this. So x square equal to 1 by 2 and x equal to 1 by root 2 plus or minus 1 by root 2. So y equal to plus or minus 1 by root 2 is x equal to y from this. So put this in this line. So root over of I equal to plus or minus 1 by root 2 plus or minus I into 1 by root 2. Similarly, this squaring in both side, then comparing the coefficient of real and imaginary part, we will get two equations, and by solving this, we will get the x and y. And root over of minus y equal to plus or minus 1 by root 2 or minus plus I into 1 by root 2. Let me check 1 minute. Uh, So y here y equal to plus or minus 1 by root 2. So as this is root over of minus y minus I, so here is minus plus I into 1 by root 2. Similarly this also. See here it is asked to prove z for verify by calculation that the values of z by z square plus 1 are both same na, sorry, those are the conjugate. That means if we put z equal to x plus iy in z by z square plus 1, and if we put z equal to x minus iy in z by z square plus 1, then we will find the conjugate. That is, the resultant of this will be the conjugate of the resultant of this. See, z equal to x plus iy, then z by z square plus 1, we get this x plus iy by x plus iy whole square plus 1. Then by computing this we get this. Then reconstructing this, x square minus y square plus 1 plus 2ixy, then multiplying this, the conjugate of the denominator in both numerator and denominator, we will get, that is, let put this equal to a and this equal to b, that is a plus ib into a minus ib. So we will get here a square plus b square, that is x square minus y square plus 1 whole square plus 2xy whole square, that is 4x square y square. And simply multiply this by the, you can get z1 z2 by this. So simplify this, then you will get this. Similarly z equal to x minus, for z equal to x minus iy, proceed by the same process. So you will get the conjugate. See here, for x cube plus xy square plus x minus I into y minus y cube minus x square by y, denominator is same in both the cases. Here plus I into y minus x square y minus y cube, here y minus y cube minus x square y. So these two are conjugate. This is obtained for z equal to xy, x plus iy, and this for z equal to x minus iy. So in the next class we'll learn about Cauchy's theorem and the triangle inequality theorem. Cauchy's inequality and triangle inequality. Thank you for watching.